Today we discuss the concept of transport phenomena, which is in heat and thermodynamics. It is very interesting topic in heat and thermodynamics. Transport phenomena means here is some quantity transfer from one place to other. Here the transport phenomena discussed in the case of gaseous system means in a gas we deal two different states, equilibrium state and non-equilibrium state. In equilibrium state, the gaseous system have common property at all the places. The most probable state of gaseous system is equilibrium state. But if we deal the non-equilibrium state of gas, we just deal the transportation of momentum, energy and mass of a molecule of gas. So the transport phenomena is just characterized by the transport of momentum, energy or mass of gas molecules or atoms must under non-equilibrium state of gas. Transport phenomena explained on the basis of movement of gas atoms or molecules. The transport phenomena is of three types. First one is viscosity, which is termed as transport of momentum. Second is thermal conductivity. Clearly it is the transport of energy. Third one is diffusion, which is termed as transport of mass. First we start with the term viscosity. In the motion of solid, due to the relative motion of two different surfaces of solid, there is a creation of frictional force. Similarly, if this frictional force is act between two different layers of fluid or gas, then this frictional force in fluid is called viscosity. In non-equilibrium state, gas may have different velocities or momentum at different layers. That means if we move from different layers on layers to layers, we have different velocities or momentum. Due to these difference in velocities between the layers, a relative motion between layers is created. Due to this relative motion, there is some forces act between these layers. This force is called viscosity of the gas. So the viscosity is just a transport phenomena because it is the transportation of momentum. Here in the figure we have three different layers. In the midway and AB layer have the velocity v. Then EF is just some extra velocity where dv by dz is the velocity gradient which is changed along the direction of z, and the lambda is the free path, mean free path between the layers. Similarly, CD have some less velocity than the layer AB. Due to these different velocities at different layers, the viscous force act between these layers. Here it is clear that the layer moving faster will create momentum to the layer moving slower. And due to this, the equilibrium state is maintained. Second one is thermal conductivity. We know that the gaseous medium move energy faster than any other. Thermal conductivity means there is a transfer of energy, transportation of energy from one position to other position in a gaseous system. It is also called transport phenomena because here to deal the thermal conductivity, we just deal the transportation of energy during the system. We know that the different layers of non-equilibrium gas may have different temperatures. Due to difference in temperature, there is some amount of heat will be exchanged from one layer to another layer, because the motional molecule will carry kinetic energy or heat from region of higher temperature to the region of lower temperature, and that create equilibrium state. Third one is the diffusion. In the diffusion process, some molecule move from one place to other. That means there is a motion of mass from one point to other. So diffusion is also a transport phenomena. We know that the different layers of non-equilibrium gas have different concentration. Concentration means number of molecules per unit volume. Molecule of gas will move from the region of higher concentration to the region of lower concentration and finally comes to the steady state. Here in the figure AB have the numbers n, molecules n, and dN by dz is the gradient with changes from the values of z. So it is clearly mentioning that these three phenomena, viscosity, thermal conductivity, diffusion, are termed as transport phenomena because they deal with the transportation of momentum, energy and mass of a molecule of a gas or atoms.